Hello students! When analyzing DC circuits, we can use either the voltage source model or current source model of the original circuit. However, analyzing certain physical quantities using these models can become more complicated. If there is another way to make the circuit analysis simple, we will give priority to it. Today, I'm going to introduce you to a new method, the equivalent transformation of power supply. When representing the same power supply, it can be expressed as either a voltage source or a current source. For the external connection circuit, both the voltage and current from these two power supply models are equal. This means that the effect of these two power supply models is inevitably the same, and an equivalent transformation can be carried out between them. During the equivalent transformation between the two power supply models, the numerical relationship between the number of voltage sources and the value of current sources follow Ohm's law. However, the internal resistance remains unchanged during the transformation process. The principle of equivalent exchange is applied when the external loads are the same, and the voltage and current of the external circuit are equal. As shown in the following figure, if we want to transform the actual voltage source on the left into the actual current source on the right, everything remains the same. Before and after transformation, the magnitude of the internal resistance R0 of the circuit will not change. The magnitude and direction of the terminal voltage and current for the external circuit also remain unchanged after the equivalent transformation. If we change the voltage source into a current source and change the internal resistance into parallel, the current of the equivalent current source is equivalent to I sub s equals U sub s over R0. If we want to transform the actual current source on the right into the actual current source on the left, everything remains the same. The magnitude of internal resistance R0 of the circuit before and after transformation still remain unchanged. After the equivalent transformation, the magnitude and direction of the terminal voltage and current of the external circuit also remain unchanged. If we change the current source into a voltage source and change the internal resistance into a series connection, the voltage of the equivalent voltage source is calculated as U sub s equals I sub s R0. For example, given a voltage source U sub s equals 12V and R0 equals 4 ohm, we need to find the current source after equivalent transformation from the analysis of the problem. In order to convert the actual voltage source into an actual current source, the magnitude of internal resistance R0 of the circuit before and after transformation will not change. Instead, internal resistance changes to parallel connection. Therefore, the current of the equivalent current source after equivalence can be calculated as I sub s equals U sub s over R0 equals 12 over 4 equals 3A. The magnitudes and directions of the terminal voltage and current of the external circuit after equivalence remain the same, which means that the current direction of I sub s is from bottom to top. Taking another example, given a current source, I sub s equals 2A and R0 equals 8 ohm, find the voltage source after equivalent transformation. It can be obtained from the analysis of the questions that, in order to convert the actual current source into an actual voltage source, the magnitude of internal resistance R0 of the circuit before and after transformation will not change. Instead, internal resistance changes to series connection. Therefore, the current of the equivalent voltage source after equivalence can be calculated as U sub s equals I sub s R0 equals 2 multiple 8 equals 16V. After equivalence, the magnitude and direction of the terminal voltage and current of the external circuit remain unchanged. So, the voltage direction of U sub s is up positive and down negative, or we can say it is from top to bottom. It is not difficult to find that when two actual power supply models are transformed, attention should be paid to the following issues. 1. The direction of the voltage source from the reference negative pole to the reference positive pole, and the reference direction of the current source should be consistent before and after the transformation. 2. When transforming the two actual power supply models, it refers to external equivalence, which means that the calculation of each part of the external circuit is equivalent. But for the inside of the power supply, the calculation is not equivalent. 3. The ideal voltage source and the ideal current source cannot be transformed equally. 4. By using the equivalent transformation of the two actual power supply models, the analysis and calculation of the circuit can be simplified. This section has ended. Let's think about: can ideal power supplies be equivalently interchanged? What about the interchange between actual power supply models? As for more knowledge, see you next time.